So I will be giving you resources in addition to the exercises that you need to complete. And always there's the textbook you need to read and the videos that you need to watch. And then I'll give you the extra study guides that will help you then with the final exam. I'm glad you had a good experience with the midterm exam. It kind of was the first one, so now you know what to expect for the final exam. So I think a little bit of that unknown pressure is gone. Sometimes the unknown can be very stressful, but now you've taken your first one and you're good to go. And as soon as I get stuff like that, I will then give them to you so you can get ahead and starting. But every week I will give you the presentation. You have topics for that chapter or that week, and those topics you can start already preparing for the final exam by having some good references for yourself. You have the topics for each week. Make sure you understand each of those topics. Write out, a brief description and information, and maybe even pages in your textbook that you can go back to when you are studying for the final exam. Also, complete the extra exercises and questions, and also there's section numbers associated with them, so mark that down, then you know again what to review when you come to the final exam. So it'll be a lot of good, I know it's a lot of information, but if you do some of it every week, then you won't be so overwhelmed when it comes to the final exam. So start preparing every week, understand the material for that week, then when you come to review it for the final exam, it won't be as much all at once. Do a little bit at a time. That's the best strategy. Okay, there's nothing to review now, so we're starting kind of like with a fresh slate when it comes to what we're going to be exploring and discussing. For week 9, I guess I should wait. We do not start until the hour, so maybe I'll wait till everybody else comes. So I'm hoping all of you are well. I know you're all happy to be back in class. You all like to learn material, and you're all very smart. And you all know how important your education is to you. And when it comes to computers, anything about computers, any knowledge on computers is very valuable. It really sets you apart from everyone else, because computers are so important. No matter what area you go into, you have to know computers. You have to use computers. So the better you know it, the more you know, then the more you will stand out from the crowd. So as I mentioned before, the best strategy, at least know what's in front of you. Get to know your own. Use your own computer as a case study. A lot of the information you will learn from your computer will apply to other computers. There might just be some slight variations, but technology is pretty much together, and it's always advancing. So it's a good idea also, if you can, to join some professional networks. So when new research comes out or new standards come out, you will be aware of it, and then you can be a good asset for any place that you work at, because you will already know what's coming in the future. So that's a good strategy for you. I do not know if there's any student organizations at your school. If not, maybe you want to start one. There's international organizations such as ACM and IEEE. I put this down. So ACM, IEEE. These are very international standard organizations that pretty much set what is done in the workplace. They're already researching for the future, and as soon as their research is done, typically that is what you will see being done in the workplace. And also your companies, know what Microsoft is doing, know what the the GNC group or the group for the open source software. You know, you have to keep current. Things change all the time, and you can't go back to school every time there's something new. You kind of have to learn how to learn on your own. So the best is to, again, explore, maybe take a little bit of time from social networking with your friends, take a little bit about that time and use it then to look at what Microsoft is doing. Look at what Cisco is doing, a leading area in networking. Look at what Oracle is doing, leading organization for databases. Or look at what all the notebooks or iPads, what are the technologies now for mobile devices. That's a very, very popular area right now because everybody has mobile devices. So they're all scrambling now to create things better for the mobile devices in hardware technology and software technology. So the only way for you to know about it is to learn about it. So hopefully you have a good routine every day, learn something new about the computer or learn something new about what's out there now. What is it that they're doing? So that will make you a very knowledgeable IT professional. There's a lot of IT professionals out there, so you have to know a little bit more to show that you're better. So every day, again, do something to learn more about computers, and that will be very beneficial for you not only in school, but also in the workplace. Okay, so week 9. Week 9, we are starting mass storage structure. This is about everything but RAM. We already talked about RAM or memory. So now we're going to talk about all these storage devices. There's many that are out there. But again, the operating system has to manage it. If it's going to be used on your computer, the operating system needs to know how to set it up so it could use it. So when you store a file on your hard disk, it has to know how to put it there, and it has to know how to get it back in case you want to work with it. So there are many types of storage devices. At least know what's on your computer. Find out what you have. Look at the manufacturer. What company made your devices? How much storage do they have? Maybe even look, how do they work? You know, what is the hardware? How does it get material? How is the data put on it? So those are good areas for you if you haven't looked at it yet or started it. I'm sure in your introductory computer classes you maybe looked at some varieties and some material that's used. We're going to be looking more specifically as to how an operating system manages it. So operating systems obviously differ. That's why when you have anything, if you buy any piece of hardware or a storage device, they have to know what kind of computer you have so that the storage device is compatible with your computer. But some of this can be added later after you buy your computer. So you can purchase additional storage devices and attach them to your computer. And these days, the way it goes, our applications are so large and our media is very rich. Videos, music take a lot of space. They're large files. So you can supplement. You know, you can always just go buy a new computer that has more storage, or I don't know how practical it is because you probably have to be buying new computers every 6 months. Or learn how to use your computer and add additional storage devices to your computer. Find out if you could do that on your computer. Find out what you can add to your computer. It would be, again, beneficial information for you to know, especially in a workplace where more than likely they're going to need always more storage. So what are the options? They're not going to buy all their employees a new computer every time the computer runs out of storage. No, they have to have some strategies to just add more storage, not always buy new computers with more storage. So anything with storage is good knowledge to have, because that's something that always is needed. Because again, as things add up, as you get more applications, more software, you have to store it somewhere. And then when you have, as you go on in the workplace, there's always going to be more files that are saved and stored, and this information needs to be kept. So the hardware components and capabilities are good to know, and then the operating system, because that will determine what can the operating system manage. How many can the operating system manage? And then how does it manage? So we'll be looking at all these different aspects to mass storage devices. But it's very similar in strategies, just like we looked at when we looked at memory. Still has to manage, there's different components, there are addresses. The only thing is they're not on actual board inside the computer, but it may be. I mean, there are some mass storage devices that are actually put on a board and put inside your computer. So they can be internal, they can be external, but the difference is that they're permanent. So they're a permanent version of storage, whereas RAM or memory is not permanent, it is temporary. So we're looking at all permanent versions of storage. So we're going to look at some of the types. We're going to look at the structure, the basic structure, because that way we'll know what is it that the operating system is working with. You know, there is a device, there is data on this device, so how does it determine where your file starts and your file ends when it's on this CD, or it's on this DVD, or it's on your hard drive? It has to keep track of where it puts things, so later when you want it, it can bring it back. So we'll look at the structure of a disk, because the structure is what is used to determine how the data is stored. Disk attachment. One thing is, every disk, you have a hard disk, and then you have a hard disk drive. You always have to have some kind of device that reads it. You can't just have a CD and put it on top of your computer and expect it to already read what's on the CD. No, you have to put it into the CD drive or a DVD. You can't just put it on your table and then expect the computer to read from your DVD drive. No, you have to put it into a DVD drive. I'm sorry, the DVD itself. So you always have something that has the data, and it has to be put into something that can read the data. And then that's your attachment or your reader. And then it has to be scheduled. Just like we know, when you schedule anything, it's pretty much just like an input-output process. We did touch upon that when we talked about processes. The operating system does distinguish an input-output process. It kind of has its own little queue. It has its own little schedule, as opposed to other processes. It is kind of separated only because input-output works the same no matter when or how it's used, because it has to come from the input-output device. So it's coming from somewhere else. So it's kind of treated a little bit special. And then also the operating system is responsible for managing what's on the disk. The CD, DVD, hard drive, solid state, tape. Tapes are also storage devices, so it has to manage it in the sense that it kind of labels things. It kind of puts like tracks. You have tracks on a DVD or CD. It kind of starts setting up these little sections on the disk so that it knows that when it puts something in on the disk, it records what section it's on, what side it's on, so that later when it needs to go get it, it knows where to go. It will direct the reader to go to that location and then extract the data. So we'll be looking at all this different information. Okay, any questions so far on anything? Did you find all the readings and the videos? Okay, they're all displaying on the classroom so that you can start reading the material. Hopefully you've already started reading the material and looking at the videos. Again, the sooner you start, the more time you have to make sure you really understand it. Any questions on any of this yet? Anybody? Any questions? Okay. I know you're all rested after your break and ready to go. Okay. So you're going to look at chapter 12. And then you have some videos here. One is for the chapter and one is on algorithms. Yes, our lovely thing. Not yet. I know. That's okay, though. Once you get started, then you know you're going to have 5 or 6, 7 more weeks. So the sooner you do, though. But again, don't forget, start preparing now for the final exam. Get the topics, write out descriptions, identify what sections this material is on. Look at the exercises, look at the optional exercises and questions. Start now making little references for yourself or making little notes for yourself that you could use then when you study for the final exam. If you break it up into every week, then you just have a little bit of material. If you keep everything to the end, then you're going to have a lot of material, and it's too much to really know well. So know everything as you're introduced to it, because this way it really will stick with you. Remember, you may pass the exam in the classroom, but you really have to know the material in the workplace. You can't fool anyone in the workplace. If you've got to create something or do something for a company, you can't scratch your head and say, I don't know. I mean, yes, to some extent, yeah, you could work together with your colleagues, but really, you're hired, and once you start in paid money, you got to know what you're doing. Or learn how to know how to find out what you're doing. Okay, these are the assignments. That is correct. Yeah, once you're being paid, it's very simple for them to say, you don't know it, then they'll just say, goodbye, go get another job. So the more you know, it's called job security. Then you're an asset to the company. So that's why it's important. Know the future of what's coming. That will be very helpful for a company. If you know what should be coming in the future, so what should be done now to prepare for the future. That's very important for a company because they have to be on top of everything. They have to be using the latest technologies. Otherwise, their competition, if they are using the latest and they're not, then you're going to lose business. So it's all about business. It's all about money. Okay, so this is your homework exercise that you will need to complete, again, by Saturday, Saturday midnight. So you got a kind of light week. You only have one. But of course, don't forget, in my office hours slide, I gave you 10 more questions for you to look at. So we will go over them next Monday. Every Monday, I'll give you new questions, and then the following Monday, I'll give you the answers. So work together on it. You know, explore it when you have time. Again, it'll just help you learn the material better. I can't put it into your brain. Only you could put it in your brain. So find a way that works for you to put it in your brain. It would be nice I could just put a chip into your brain and it works, but I can't do that. We're not there yet. Maybe one day you can have a chip in your brain, but we don't have that technology yet. So you have to put it in your brain. I can't do it for you. Okay, so we have a whole variety of types of disks. And there's a whole variety. You find a way to put it into your brain. I wish. Okay, as soon as I get it working on myself, then I'll come to you and help you out. Okay, so discs. Discs are removable. That's a good thing. Even though you may have a hard disk in your computer, it really can be taken out and put in a new one. Some people do that when their hard disk crashes or gets broken. They take the old one out and they put a new one in, and then hopefully they transfer the information from the old one to the new one. So that's how you can add a new hard disk, or if you have to because your first one is broken. Anything mechanical, remember, anything electronic, mechanical can break down. So a good strategy is don't rely just on one disk, because what happens if that disk dies or breaks? Always have at least 2 ways that you're storing your information. That's why backups are very important. Have another way or another copy of your data. Always, always, always. There's a lot of variety. There's your flash drives, there's external hard disks, but never leave your material just as one copy. Because even with viruses, you know, your computer crashes, you can't even get to your material. Then what are you going to do? So always have copies of all your data, and preferably have a copy somewhere away from your computer. Because if your copy is on your computer and your original is on your computer, but if your computer breaks, you may not even be able to get to the original or the copy. So that doesn't really help you too much if they both can't be accessed. So make a copy away from your computer some way, somehow. There's a lot of devices out there that you can use. Okay, so the overview here kind of talks about the different varieties. Again, it has to be, every disk has some kind of reader, some way that the material can be read off of the disk, and then the operating system has typically a device driver, which is the software for this reader. So there's always hardware and software. And depending on what you have will determine what kind of reader you have, what kind of device driver you have. Every device has its own driver because it's made by a particular manufacturer, and it has specific specifications, and it's those specifications that you have to write the device driver for. You cannot use a device driver from one device and hope that it works on a different device. They are very specific. Once you get specific to a hardware, that means it's unique for that hardware only. So again, depending on how it plugs in, your hard disk drive is mounted inside your computer, so access comes from a bus. We know about the internal communication on buses. There's plugs, there's externals that can go into your USB ports. So there's a lot of different components. It is hardware. Hardware is specific and needs specific programs, and the operating system needs to either have these programs or work with these programs so the data can be transferred. We already know anything processed in the computer has to come from RAM. So the whole purpose of the operating system, it has to work with this disk drive and get the material from the disk into memory. And that typically is what takes the most amount of time on your computer, is the transfer. When things are processed from your processor to RAM, it's very fast. It's waiting. If you have to wait from stuff from your hard drive to put it into memory, that is what takes the time. So this is an example of a disk mechanism. These have several disks. And then again, it's hardware. There's hardware here. There's a read-write head. There's your reader. Remember, every disk needs to have some kind of device that reads it. All depending what it is will determine what kind of reader it needs. And then everything is broken up into parts. we have a track, we have a sector, we have a cylinder. So this is what the operating system uses as an address for data when it's put on a disk. We know already about addresses and memory addresses, and here they're a little bit more detailed, because we have to put down what cylinder is it on, what sector is it on, and what track is it on. Again, you should be familiar with this. If you use CDs or DVDs, you know about tracks. And it's one CD or one DVD, so you only have one cylinder or platter, but you may have multiple. Again, in the workplace, you're going to have multiple. You're not going to just have one. But at least know what's on your computer so you know what you're working with. So magnetic disks. Again, magnetic disks, it would be your hard drive. This is just some speeds. How much data I can keep. Find out how much data can your hard drive keep. So know what's on your computer. If you're in the workplace, start looking around and know what's on the computers at your workplace. That's how you learn. You got to see the stuff. Or browse on the internet and start looking at stores that sell disks and look at the specifications between them. How do they differ? Look at reviews on which ones are better than others. This is very helpful for information when you're in the workplace, because the workplace always has to buy stuff. They have to know what's out there, and you should have that information, already know it. If you know it, then again, you'll be a good asset to the company. Okay, magnetic disk performance. Again, there's algorithms, calculations, but this is based on electronics. How fast does the mechanisms work? Find out how fast does your work. Do you know how fast your CD drive or DVD drive is? So find out what yours is. Find out what your classmates or friends is. Start looking at what around you, and it'll start giving you an idea of how these things work. And then some basic information about what you see. Then you can compare it when you see something new. The first, it sounds like a good trivia question if you like to do trivia, or if you're in some contest for trivia, but it may be on the exam. I shouldn't say that. But here's the first one, and look at the size. It's so large. Yeah, in the old days, in the first set of computers, they were very, very large, not like what we see today at all. So that's very large. You have to use a forklift. Right now, you don't need a forklift when you put a CD into your computer, do you? You don't even need a forklift for your computer. You can do it with one hand. Okay, now, solid-state disks. This is when we move away from magnetic. There are problems with magnetic. I don't know if you ever heard, but sometimes if you can get things demagnified by accident. If you go through X-ray machines, it'll demagnify it. So if there's no magnetic on your disk, anything that was there stored magnetically is gone. So that's why, again, every time there's a push for new technology, that is to safeguard data and also to have the smallest device to store the most data. Those are pretty much what drives technology. But most important, we know it's permanent data. They are more reliable than hard disk drives because they are not magnetic. They are more expensive. But I don't know, the more they're being used, the more the price is coming down. And they're faster, but there's no moving parts. Here's an example. So this is what your hard disk drive looks like. Again, I mentioned there's the platter. You have an arm that reads it, and that arm can be told where to go on the hard disk drive, what sector or what track. The device driver will operate. The disk will operate that arm that comes out to read it, and it's the operating system. Then I'll take the data as it comes in and then put it into RAM. And then if you notice, the solid state hard drive is a little different. No clatters. It's not magnetic. So less prone to, obviously can't, well, this, yeah, some power. I mean, it can be damaged. Yes, anything can be damaged. But it's the frequency of how, if it can be damaged. How likely will it be damaged? Depending on what you do. Obviously, if you step on any of these really hard, you probably could damage both of them. But if you put in, the demagnetation is less. Now, we also have a magnetic tape. So anything magnetic, think of it this, anything magnetic is old style. If it's not magnetic, then it's new style. But a lot of this stuff still exists. When you own a company and it's an older company, they will have a variety. They will have it because maybe when they started the company, they had a tape because that was the latest and greatest. And then when technology advanced, they got new stuff, new devices, but sometimes they still keep their tapes because maybe there's, years and years of data on these tapes. They're not going to take the time to take the information from the tape and put it to a disk. Sometimes they do because magnetic tapes after a while do wear out. They do get bad. You can't read the data. Sometimes they just hope for the best and hope that it doesn't get damaged, but the data is so old that even if it got damaged, it would be okay. It would be better if it didn't get damaged, but it's nothing that will, keep a company from losing any business. So it all depends on what it's used for, what it is. But if the tape is, hopefully you know what a tape looks like. You've maybe worked with a tape. Maybe, I don't know, you're a young crowd. Maybe you've never worked with tapes. But here's some examples. And if any kind of storage device that needs some kind of reader, so you have a tape, and on the left and on the right is going to be your reader. So remember, any storage device or media has to have some kind of a reader. And if the operating system works with the reader. Disk structure, we looked a little bit about it. You had cylinders, you had sectors, you had tracks, you have logical blocks. Again, similar type of strategies. Never saw the tape, huh? So now you can just look at pictures. Okay, yeah, I'll put some videos up on the classroom then to at least show how they work in the, in the view. Yes, cassette, like cassette, yes. Cassette is a magnetic tape. Yes, in the old days, you know how you put your CD into a computer? In the old days, you would put an actual cassette into the computer. That was considered revolutionary and new. That was a great breakthrough when they were able to use cassette. Because before, they used to just use cards. And then they moved to the cassettes, and that was wonderful. There you go. You still have a cassette and use the cassette. But for computers, there was a time where cassettes were used. But then we got to the magnetic discs, and now you have your CD, DVDs, flash drives. There's a whole variety. Because we understand data is important. Anything you use, you need data to run the computer. You are creating data when you use the computer, and you need to keep it. You need to store it. So we have to find great ways to store it, use it, and again, process it too. I mean, for a company, when it has to maybe process 1 million customers, it's got to have something fast. It can't take 1 week to process 1 million customers because the device is so slow. It has to be fast. And nowadays, when you're online, and there's a lot of online shopping stores, that has to keep up with the demand. You have a lot of customers making orders when you're on the internet and you're famous around the world. So you got to store all that information. These devices have to work fast. Customers are not going to wait a half hour before you tell them their order is done. You're going to go to a faster store. So again, a lot of new media out there that you should be familiar with. But the old is good to be familiar with too, because again, if you go to a well-established company, if they were around, you know, for many, many, many years, they will have these also in their office and in their storage. So you have to at least know and be familiar, not say, oh my, that's so foreign, I never saw anything like that before. You maybe didn't work for it. At least look at pictures and videos, so at least in case you're in a workplace, you at least know about it. Okay, again, depending on the disk you have, these are very important items: cylinder, sector, track, and platter. That is how the operating system keeps track. It's like a table, a location table that has this information, and that's how it can once it puts the information there, it keeps track of that location, and if you need it, it goes to that location to retrieve it. Disk attachment. This is, okay, how is the device driver attached to your computer so that the operating system can put information on it and take information on it? It could be through the ports, it could be on a bus. So there's a lot of different devices. Again, look at your own computer. Find out, how is your stuff attached now? And if you needed to get more storage, how can you attach it? One thing I think a lot of devices now are using USB, universal serial buses, a USB port. All you need is a way to plug it in and you're good to go. You can plug in a lot of devices now USB. That was a good standard that came out because then any computer can use that device. Or at least that device can be plugged in. Or people can make many devices. It still depends on what kind of computer and operating system, but many companies can make the same type of a device. All they have to do is make sure it plugs in by USB. So here's some examples. There's plugs. If you get venturous, maybe you want to open up your laptop and look at it. Or if you have a desktop, make sure you turn it off before you open any device, so you don't get electrocuted. Be careful though, there is voltage. Even if your computer is turned off, there is still electricity running through it. So that's why you have to, you have to be grounded. You have to make sure you're on a rubber mat. Rubber is a good medium for grounding, so you don't get zapped by some of this electricity. So yes, you can open up your computer and look at it, but don't go so fast in touching anything because it might have voltage. But for sure, make sure that you have you have rubber around you, a rubber mat, special devices. In other words, research before you open your computer. Research on the internet, find out how to do it. You can Google anything and you get videos for anything on how to do it. So that's something that then you could do. Okay, I'm going to just take a little breather here for the grade book for your participation. I don't know if you see all my screens on here, but that's okay. Okay. So these are any questions so far? So we know we have devices. Operating system has to work on it. You have media that keeps the data. You have a reader that the operating system works with. There's magnetic, which is old style. Now we have new style. And now, again, as our data increases and our amounts that we have to keep increases, once everything started going more electronic, there's a lot of electronic data. So now there's something called storage arrays, so that you can have more than one disk, an array of disks. But one thing is, if you think of array, you already then maybe are familiar with arrays when you've done any programs. But if you've done any programming, you may have come across the data structure known as an array. So that should give you some connection right now. That's what the operating system uses, a form of an array when it comes to its data type and variable, when it's storing information on where data is stored on these disks. So right away, that's a connection to software. So right away you think of, that's why array is really created for programming, because you have a multitude of information to store. And all this is, when you say have an array of disks, yes, there's multiple disks, but also the operating system keeps track of these disks in an array. So here's an example. So you have here is a animated, or there's storage arrays up to 24 drives. And this is what it looks like in the real workplace. So if you have a chance to go into someone's data center and look around, and you get to see all these different devices. But one thing is, yes, data is kept very secure. Companies don't normally let anyone go in to look at their data. Usually you will have actually guarded rooms or guarded office space for the data. You might have to have a key card. Some of them even have biometrics where you need your thumbprint or a scanning of your retina. Because, again, we know about data is very important. There's a lot of privacy laws. We got to be, since there's so much sensitive information now, companies are keeping, they have to be stored very carefully. They can't let somebody go in and just maybe take one of these drives out and take it home with them. That would not be a very good thing. And then there's storage area network. Again, as you see how this historically moves, it moves because of the way our technology is, or the way our business is, and again, it's increased so much, and also it's so electronic. So storage area network, here's a picture of one. This is when you have a multitude. So we already know what a network is. You have a lot of computers attached. Storage area network just means that specific area of storage devices that are attached. A network can attach anything. You can have a network that has anything attached to it. You have your computers attached to it if you're working in a networked environment, and then the company will have servers attached to it and also these storage devices attached to it. So it's just a way of making sure that communication with the storage devices are done properly and the data is retrieved and the correct data is retrieved. So with networks, you typically will have a network operating system. So these are extra levels of sophistication to an operating system. Some of the newer operating systems do have that capacity. You can set it up. So you can simulate a storage area network, or it can support a storage area network. That means that there are just some switches. If you see these down in the bottom, you see the RAID, optical storage, and the tape, and these are connected to little brown boxes, and these are actually like switches. In other words, this is typical to how your computers are hooked up to a network, or networks are hooked up to other networks. So it's just an extra level, again, only because there's so much there and many requests for data. When you have a multi-user environment, everybody's trying to get information at one time or another. So it's just an extra level of management. So you would have special components to the operating system that has this capability. It's not general. It's not one of the basic. It is more a specialized then add-on to an operating system to be able to manage storage area networks. Now we have network attached storage. This looks like a play on words here. Let me get you a picture. Here we go. Network attached storage. So here are your components. You have clients, you have a local area network, You have an Ethernet switch, servers, and a network attached storage server. This is a little bit of an older picture, but again, Ethernet switches are still around, even though people have been switched out from there. It's some of the older technology. Everything now is fiber optics, but again, you might still run this. You probably will still see. This is one of the first types that were come out, and again, a company always has that question to consider. When new technology comes out, do they get rid of all their old technology and put in new technology? Sometimes no, it's too expensive. So they will have to kind of coordinate. They'll leave the old and just have new and then have them work together. So you still should know some of the old technology because it still exists. You still have to work with it. You still have to see it. It's too expensive for companies every time there's new technology to change everything to the new technology. And then, as we know, we all know about process scheduling. I mean, scheduling, similar to our process scheduling, you have disk scheduling. This is something you should know and love. You loved all those algorithms in the first part of the class. I just know you love them so much. Well, now you're going to have more. But, yeah, there's different strategies for the scheduling, just like we had with the process scheduling. But this is kind of a diagram to show. Typical thing, it's just basic. Remember, you had something that wants to be processed. If it's busy, then the other processes have to wait till it's free. Then once it's free, then it's processed. So typical, very similar cycle. And it very involves your processing and CPU and all that. So there was a bit of an information on that when we did go over process scheduling, because input-output was some of the processes that needed to be processed. There were some discussion on it and diagrams on it. So some of this should be familiar to you, and also the strategies very similar to the kind of strategies you did for processes, because input-output is just another process. So here's some strategies as to which one you should choose when. This is good information to know only because these are good questions to have on a final exam. When should you use which algorithm? So know the difference between all the algorithms. Know when you should use which one. Which ones are similar. And again, I did address some of this in the exercises, the optional exercises, so go through that. Now we have disk management. Scheduling input-output is one thing, managing now is another. And this kind of goes along with the way it creates a table and how it puts information about where data is on the disk. That's the management. But this is something we do. Anytime you go into Windows Explorer, you will have all your disks displayed. You will have your hard drive there, the DVD drive there. You will have, if you have any external devices, they will appear. So operating systems will have some type of programs and some type of GUI interface that allows you then to see your disks, to see your directories, files, folders, and so on. And one thing always that disks have to have so that they can boot up is your operating system itself. So when you turn on a computer, some of the operating system is automatically on the hard disk. That's why sometimes it will ask you, you do have that option. Where do you want to boot from? Do you want to boot from your DVD drive, your CD drive, your hard drive? You will have those options because, very important, if you don't have a recovery disk, you should have one. and you should create one for your computer in case there's a virus or there's something wrong that it won't start up. You have to have another way to start up other than your hard disk. Hard disk is the most popular because it is there. When you buy your computer, it's automatically loaded and ready to go. That's why you can just turn on your computer and go. However, like I mentioned, always have a copy. Don't rely on one version of your data, and that is including the operating system. You need to have a copy in case one crashes and have that somewhere other than on your computer. That's what they sometimes when you have a computer, it may come with it, or it recommends that you create a boot disk. Create a boot disk so you can start your computer in case your hard disk gets corrupted. But here's an example of a disk management window. It kind of shows your different disks. Here it even shows dual boot. You have Windows Vista on one, you have Windows 7 on another. So look for this on your computer. Look to see. Look in your Disk Management Windows Explorer. At least learn what's on your computer. You have them in front of you so you could use it like a case study. And this way it'll be familiar when you go into the workplace. You'll have something similar. Everything these days has like a standard way of interacting, standard GUI or graphical user interface. So look what's on yours. It'll be similar to what you'll see. But at least to get to know what's in front of you, because that's easy because you have it in front of you. And use the internet. Start looking. Like for example, if you have Windows 7, look for Disk Management, Windows 7. I will then again put some videos on the classroom on all these different. But one thing is booting from a disk in Windows. Again, it's going to boot off of your hard disk. Remember, there's some information, we did discuss this way in the beginning, first couple chapters, about how operating systems just start, how it starts your computer. Some of it is on a chip. The rest of it is on the hard disk. And then once it gets loaded into memory, then you can start using your computer. But it's important to have a recovery disk or a boot disk or a system disk for your computer that's not on your computer, separate from your computer in case something happens to your computer. Now we have a RAID. This is, again, multiple disks, multiple drives. Array, it's a redundant array of inexpensive disks. So this is very popular. You will see this in the workplace today. Because not only is it a way of storing stuff, there's already also a strategy in how RAIDs are set up and used. So it can give you backup, it can prevent or minimize data loss. There's also some programs that will help make sure. Now you have to do a checking, or it's known as a checksum. All operating systems have to have some programs that check your disk to make sure there's nothing wrong with it. It has to see if something happened. Otherwise, if something's wrong, something happened, and it's trying to read something, and it just can't, there has to be some way to check why, and to let you know what is the problem or what's the possible problem. So it's a program that normally checks. It routinely checks. But these are different RAID levels. Again, having the RAID already is built into some strategies how to deal with your data to make sure that, again, you can't have bad data. So there's something known as ZFS, which checks all the data, and it is a routine that's done. It should be a routine if it's not. It doesn't prevent or detect data corruption or other errors, it's just disk failures. Okay, so again, that's just to make sure your platter is not cracked, or there's not a crack somewhere, or half of it is missing. So this is some strategies. Again, this is all software, and I do have a link here you can go if you want to learn more about it. So we had a little bit of hardware, a little bit of software. Some of the topics or strategies should be familiar. We know something has to be scheduled. Very similar to any process. It's just an input-output process. You know you have some hardware. Similar, instead of memory chips, you now have these storage devices, and the devices will come with a device driver because there's so many different kinds and types. That's why operating systems, some of them are known as plug and play. Do you know what plug and play means? Anybody? Plug and play on a computer. Are you there? Hello? Yeah, that means it's already included in your operating system. It does need a driver, but the operating system, it's just so common that it automatically comes with it. So that's the plug and play. Typically, when you put something in, a screen will come up and ask you, you know, is it in the list? If it's in the list, then you could just use it. Right, you don't have to install it. So either your device typically will come with the driver, but you may already have it in your operating system, so you can just use that. But if your operating system doesn't have it, then you will have a disk that comes with your device that you will then put in and then set up the driver so you can use the device. So that's how operating systems then accommodate all these different devices. Again, get to know what's on your computer, know what kind of hard drive you have, or hard disk, and all your other drives, CD drive, DVD drive. What is the speed? What is the size? What company makes it? Then when you know what you have, go on the computer and review or compare it to what's out there. How does it compare? Is it the best one that's on the market? Is there a better one? Is it an okay one? So that's a good way for you to know if you got a good deal on your computer depending on what's inside of it. Any kind of part. What are the parts? Very similar to buying any kind of mechanical device. Does it have good parts? So here you should know then you have a chance to know the specifics of your own computer. Okay, if you don't have any questions, then I'm all good. If you have any questions, if not, again, start looking at the resources. There is the exercise due by Saturday. I will post these slides in the discussion forum. There's also a discussion thread for you then to share your experiences. You know, here's where you can list what do you have on your computer, what does it have, so then you can compare with each other what you have. And it would be, again, it's helpful to your classmates if you share what you have, because then they can share what they have, and this way you'll know at least a little more. You'll know more than what's just on your computer, because then you could see what your classmate has, or share what you see in the workplace. So again, it's very beneficial for you to know these things. It will set you apart in the workplace. And companies need employees that have this extra information, because companies always have to buy new things. They always have to determine if they need new equipment. And for you to know what's out there and the latest, the greatest to come, then you'll be a good asset to the company. They'll be very thankful to have you, and very thankful that they hired you, because you can help them. You can help them save money. You can help them. Nobody wants to buy old devices by accident. You know, they update the lab and they get old devices, and then they're not going to be good in the next couple of years. That means they wasted a lot of money because they're going to have to buy new equipment. So knowing what's out there is the best. Okay, so enjoy the material. Welcome back. And if you have any questions, don't hesitate to post them in the discussion forum. We can all work together. And I think this week, at least, you only have one question to answer, except for the extra ones I gave you, but a little bit easier on the homework, so that our assignments, so that you can get used to being back in school and ready for more material as we go on through the next weeks. Okay, have a wonderful evening, and I will see you Monday. for sure, for office hours if you like. And again, any questions, put them in the discussion forum. Work on those extra optional exercises. And keep learning. Again, I can't put it in your brain and make it stick and stay. Only you can put it in your brain. So work on it to make sure it's in your brain. You're the one that's going to benefit in the workplace. And you can't fool anybody in the workplace. It really has to be there in your brain. Otherwise, they can tell very fast if you don't know what you're talking about. Okay, take care. Bye-bye. And thank you for joining me.